So you guys, let's continue with our system design thing. So right now, what we will do, we will have we were working on background jobs, right? So the first thing, the first type of background jobs are event-driven jobs. So let me just try to explain what this means. So what are event-driven jobs, right? So event-driven invocation uses a trigger to start the background task. Examples of like using event-driven triggers include. So what do we do here is we trigger any background task based on any event that got triggered, right? So the first example can be the UI or another job places the UI or another job places the message in queue, right? You know how message queue works, right? So in MQ, we place one message via UI, right? So UI places one message in MQ. So the message contains some data about an action that has taken place, right? Now, such as the user placing an order, right? So let's suppose that a user has placed an order. Let's suppose this message is about order, and this order object contains some details about order, right? Details on order. So it's an object contains a detail, right? Let's suppose spread operator. So the background task listens on this queue and detects the arrival of a new message. It reads the message and uses the data in it as the input of the background job. This pattern is also known as asynchronous message-based communication. So what it does, it uses this details inside this data for the input of the background job, and then it starts the background job, and this pattern is also known as asynchronous message-based communication. Async message-based communication. Okay, so this is the first type of event-driven jobs. Second type, this is the first type. This is the second type. Let me move it a little down. Now the second type is the UI or another job saves or updates a value in storage. There's a storage. From storage, it will try to pick, right? So if from UI or any other job saves message or any data or flag in DB. So the background task monitors the storage and detects changes. So it will try to monitor this storage. It will try to check if any changes are there, if any changes in DB. It reads the data and uses it as the input to the background job. So it reads the data and take it as an input for the background job. I'm just labeling it as BG. Okay. So then we get the input from this storage. The first is of course the message driven. The second is storage driven. Now let's go to the third one, which will be I think third one, which will be so it will be endpoint driven, right? So endpoint. So what will happen here? The UI or another job makes a request to an endpoint such as HTTPS URI or an API that is exposed as a web service. It passes the data that is required to complete the background task as part of the request. The endpoint of or web service that invokes this background task, which uses the data as its input. So it's basically we will create an API which will invoke our background process, invoke our background job, and the data that we will be passing in this API will be used as an input for this background job. Okay, that's basically three types of background jobs in event driven. Now comes schedule driven, right? So this was all about event driven. Now comes schedule driven, right? So there are two types of background jobs. First is event driven, second is schedule driven. Okay. So schedule driven. What is schedule driven background jobs first, right? So schedule driven invocation uses a timer to start the background task. So this is a timer based, or what you can say date based. So date or timer based. Basically, it gets triggered when the time comes. Now, basically, example of schedule-driven triggers include. Let's talk about example of this. The first is a timer that is running locally within the application or as a part of application's operating system invokes background task on a regular basis, right? So let's suppose you know about cron job. So cron job, how it works, it invokes at regular, it tries to check that it keeps running regularly, or we can also run it every 2 or 3 seconds. So this is also sort of a schedule driven background job, right? So it's an example of that. And it runs locally on the application, right? The second can be a timer that is running in a different application, such as Azure Logic Apps, sends a request to an API or web service on a regular basis. So this can be like uptime example that we saw earlier, right? So it sends regular signals, or it try to check if the website is up or not, right? So that can be part of this. So what the definition of this is, another application, outside application, we can say outside application will send API request to our website, our server actually, not website. Okay, so our server, it will send on regular intervals, right? So it will send messages on regular intervals to invoke the background process, right? So when we send, let's suppose there is a cron job on this outside app, and that is sending API request to our server to invoke the background process, or BG, whatever you want to say. The third example can be a separate process or application starts a timer that causes the background task to be invoked once after a specified time delay or at a specific time. So let's suppose there is a process. Let's suppose P1 process and P2 process. P2 is, so when P1 starts, after it starting, when let's suppose it's completed, then after that it invokes P2. So it invokes P2 is a background job. So this can also be a type of schedule driven background job, right? So after a specified time delay, or it can be like if P1 has started now, P2 will get started after 3 seconds of P1. It can also be the example of it, right? Typical examples of tasks that are suited or to schedule-driven invocation include batch processing routines, such as updating related product list for users based on their recent behavior, routine data processing, such as updating indexes or generating accumulated results. So batch can be example tasks like processing indexes. So updating indexes in which means whenever you open your MacBook, right? So whenever you open your MacBook on this, when you press Command CMD plus space, you can see that below that there, whenever you start your MacBook, there is a loader, right, which says indexing, right? So that is also a type of background task. So whenever you start your MacBook, even if you don't click on search, it will keep on running in the background. So that is also a type of background task. Data analysis for daily reports, data retention, cleanup, and data consistency check. So these are about. This is all about schedule-driven task. So we have learned about schedule-driven and event-driven background jobs. Now let's learn about returning result. Returning results. Returning results means after background task, background job, or background task or process is run, what is the returning results? So like background jobs execute asynchronously in a separate process, right? Or even in a separate location. So from the UI or the process that invoke the background task, that ideally background tasks are like fire and forget operations, and their execution process like has no impact on the UI or calling process, right? So we cannot track when it's completed. So like therefore like we cannot automatically when like if you start the process, if you start this, wait a second, if you start this background process, it gets started, right? It will run on in background. We cannot detect because it's independent of the current node or application or the UI that we are running. It's independent of that, right? It's running in the background, so we cannot detect when it is completed. So that's a drawback, sort of. Cannot detect when completed. So that is a little drawback of this. Okay, that's about background job. Now let's learn about DNS. DNS is a really interesting topic. DNS, which is the full form is domain name system. Okay, so what is the domain name system? You know about this, right? Let's suppose www.google.com, or let's suppose it's an example.com. Example can be, it can be any domain, right? Google or Netflix or Uptime or LinkedIn, Facebook, Instagram, anything. So those are all are domains, right? So this domain, whatever domain you have, what it translates to, it translates to an IP address, right? So that IP address loads your website. That's how it works, right? So like DNS is hierarchical with a few authoritative servers at the top level. So like your router or ISP provides information about which DNS server to contact when doing a lookup, right? So whenever you look up for this google.com or example.com or let's suppose facebook.com, FB or Insta or whatever social media or uptime. So what happens in the background is your ISP, internet service provider, which is ISP, it looks into the lookup information about the DNS and try to make sure it maps it to the correct IP address from where your website can load. So lower level DNS server cache mappings, which could become stale due to DNS propagation delays. So DNS results can also be cached by your browser, or it can be caching can happen on your browser as well. So internet services. This is like IP address to map to IP address. Okay. By the time TTL. Okay. Determined by the time of TTL. So it will look. So if you whenever you work on domain, so whatever service provider you have this field known as TTL in that time to leave. So this can be updated to like 1 hour or 30 minute or whatever that you want as fast you think your internet provider or domain service name or hosting provider can respond as fast as. If you think it's slow, then keep it to 1 hour, 2 hour, whatever you want, right? Now comes NS record. What is NS record? NS record, or you can see it's a name server. Okay. So what it does, it specifies DNS servers for your domain subdomain. So it specifies DNS server for your domain or subdomain. Now comes MX record. So these are the fields that you can update when you buy a domain and you want to attach a hosting to it. So what is MX record? It's for me. It stands for mail exchange, right? If you have mail, like let's suppose I have my Facebook account and I have like romil@peace.com. Okay, so if I want to use or send email to this, then I need some MX record, right? So it specifies mail server for accepting messages. Mail server for accepting messages. After MX record, there is A record, which is points. What is A record? A record basically it points to IP address from where your website should load, basically hosting provider. So address of your hosting provider basically. Okay. So that's what A record is. Now what is CNAME? Also known as canonical. Okay. So what is this? It points name to another name or CNAME like example.com or www.example.com. CNAME means what domains you want to register, right? So example.com, www.example.com. Okay, when a record. So you want this CNAME to navigate to this e record. So what CNAME should navigate? One can be this, one can be this, and one can be like, if you want, you can also subdomain, which will also navigate to your this like .com slash something. Okay. So we learned about NS record, we learned about MX record, mail exchange, e record, which is IP address, CNAME, and NS name server, ISP, TTL, time to leave, and all right. So what are the services? Services like such as Cloudflare and 53 provide manage DNS services. Some DNS services can traffic to various methods. Okay, so that was all about DNS, I think. Now let's learn about CDN. What is CDN? CDN is also a very interesting topic, which is content delivery network. So what is CDN? CDN is basically used for caching, right? For proxy servers. So a CDN is like a globally distributed network or proxy server of proxy servers serving content from location closer to the user. So let's suppose that we have a tower, not tower, it's not tower actually, my bad. It's a server. So let's suppose we have some servers. So there are some servers near to your, this is our user, this is Mumbai location, and we have server near to the user, but the main server lies where? In US. This is the main server. Main server is a proxy server which acts as a middleware. Right. So what proxy server means? So this lies in New York. Okay. The company is in basically the company is established in New York. So whenever the user is in Mumbai or in India, right, he is in India. So the device that he has to fetch the data from this, and if this doesn't have that data, this server will try to New York. and after fetching it, it will try to cache it here. Then user, whenever in future if it fetches, it can easily fetch from this proxy server. So that what CDN works, how it works like. So generally like static files like HTML, CSS, JS or photos, HTML, CSS, JS, photos or videos are served from this CDN to the proxy server, okay, to the user device. User device can be laptop or anything, okay, is surfing from. Some CDNs like Amazon's CloudFront support dynamic content. The site's DNS resolution will tell clients which server to contact, okay. So dynamic content is also possible. Serving content from CDNs can significantly improve performance in two ways. Like using CDN can improve your performance of your website, right? So it's recommended to use CDN. Some there are like free ones also available. One is like Cloudflare, if you know. Cloudflare is all provides free CDN. Okay, and so what are the benefit? What are how it can improve the performance? Improving performance. How it can improve performance? It can improve in two ways. The first is user receive content from data centers close to them, right? So it's faster data retrieval. Second is what? Your servers do not have to serve requests that the CDN fulfills. Okay, so load on server reduces. Load on which server? This is the actual main server. So the load reduces, right? So these are the two. Load reduces because the requests that are served by the CDN doesn't go to your main server, and of course the faster retrieval because connects with the CDN. So that's what content delivery network is. Now there are two type of CDNs, pull CDNs and push CDNs. Let me explain you. Okay. So first let's study about pull CDNs. Pull CDNs. So what are pull CDNs, right? So like pull CDNs grab new content from your server when the first user requests the content, right? So let's suppose you have this user which is happy. He finds some movie on Netflix, which is not recommended by the way. He searches that movie and finds it. Now what happen? The Netflix, by the way, Netflix also have its own CDNs. I don't remember the name, but yeah, they do have their own CDN. So if that data is not found on the CDN, what it CDN will do, it will pull the data from the main server when the first user requested. Right? So that's this is the server CDN. It will take some time to load because it's the first time, right? So you have you leave the content on your server and rewrite URLs to the point to the CDN. This results in a slower request until the content is cached on the CDN, right? As I said, it will respond slow. The response will be a little slow. So that will be there. Time to live determines, and the time to live like TTL that we discussed earlier determines how long content is cached. How long content is cached. So Pool CDNs minimize storage space on the CDN, right? Pool CDNs, this type of CDNs minimize storage space on CDN because whenever the user first makes the request, it tries to pull the image. We don't need to cache everything on the CDN, right? Before any user. So, but it can redundant traffic if files expire and are pulled before they have actually changed, right? Like if on the main server, some files which are changing or in the process of changing, and it pulls that content. So what happens? It got unchanged file or files that were middle in the middle of getting changed. So that's one con. And sites with heavy traffic work well with pull CDNs. Like sites which are with heavy traffic works well with pull CDN because the one time if any one user have like let's suppose I'm searching for washing machine on Amazon, so it pulls data from the main server to the CDN server, and then whatever other users try to search for a same company of washing machine, they will get data quickly because one user has already pulled the data, and for first user it will take some time, then it will happen at lightning speed. So that is also a pro. So as this traffic is spread out more evenly with only recently request content remaining on the CDN. That's the benefit of pull CDN and cons of pull CDN, right? Now let's learn about push CDN. Push CDN. Okay. So what is a push CDN? Push CDN receive new content whenever changes occur on your server. Okay. So what happens? This is a user. It doesn't depend on user. I search for movie, whatever movie. Okay. Searches for movie on Netflix. But what happens? This is our CDN server. This is our main server. Main server. Location can be anywhere. Okay, this is our CDN server. Okay, so it pulls. It our main server pushes data whenever there is a data change on the server, right? Whenever data change occur, it will be like this: data change on main server, push data to CDN. That's how it will work. Now you take full responsibility for providing content, uploading directly to CDN, rewriting URLs to the point to the CDN. You can configure when content expire and when it is updated. Like content is uploaded only when it is new or changed, minimizing traffic but maximizing storage, right? So traffic is minimized, but the storage, of course, if you push all the data, even if it is not required by the user, if he has not submitted, we try to push all the data on the CDN, right? So that's it will take, of course, it will take some storage. So sites with a small amount of traffic or sites with content that isn't often updated work well with CDN, right? So content which is not updated more frequently, that type of website works good with the CDN, right? What can be this type of website? This type of website, I think it can be Netflix because content doesn't change, movie remains same. It can be Amazon, content doesn't change, right? Facebook, LinkedIn, content changes every time, so they cannot be. They need to use a full CDN, right? Full CDN can work on this type of. TikTok can use full CDN, but I think according to me, Amazon, Flipkart, e-commerce type of website or movie surfing website, web series, they should use push CDN, right? So content is uploaded only when it is new or changed. Also, sites with a small amount of traffic or sites with content that isn't often updated work well with this push CDN. Content is placed on the CDNs once instead of being repulled and read. So this is a good example actually. So that's all about type of CDNs. Now comes load balancers. Okay, so load balancer is a really interesting topic. Let's learn about this load balancers. So what is a load balancer? Try to stop the video and try to have any definition according to the words that you are hearing. What is a load balancer? Load and balance. Just try to imagine what it can be. Okay. Okay. So did you get it? If you are saying managing the load or balancing the load across the server, then you are absolutely correct. Okay, so how it works? Let's learn the definition of this. So load balancer basically distribute incoming client requests to computing resources. What can be computing resources? Those can be servers, right? So like application servers or databases, right? In each case, the load balancer returns the response from computing resource to the appropriate client. Okay, so what it does, let's suppose that we have some servers. This is our load balancer, this is our users, these are our happy users. They they put some requests, they are requesting some content. What load balancer does, it checks whatever, it balances the load across all the servers as one as two. These are computation devices, right? And make sure that the response that we get back from here, it's served to the correct user. So that's all the part load balancer manages. Okay. Now load balancer are effective. Load balancers are effective at what? First is preventing requests from going to unhealthy servers, right? Preventing requests going to unhealthy means which are already occupied unhealthy servers, right? That is the first benefit of using load balancers. Preventing overloading issue, right? Of benefits, right? What I'm doing is benefits, right? Preventing overload issue. Third is what? Third is helping to eliminate single point of failure, because even if one server dies, other two are there for serving the request. So it eliminates SPOF, the single point of failure. Now, load balancer can be implemented with hardware or with software such as HA proxy. Right. Now, additional benefits. Load balancer can be implemented with hardware, expensive, or with software HA proxy. And HA proxy is a good example of load balancer. Okay. So S3 also provide inbuilt load balancer. You can use that as well. S3, not sorry, Amazon Web Service. It also provides it. Now, what are additional benefits? So SSL termination. Also, what SSL termination termination means it tries to decrypt incoming request and encrypt server responses. So backend servers do not have to perform this potentially expensive operation. So whatever incoming request that we have on the load balancer, it tries to decrypt those requests so we can get the pure data. And whenever sending back the response, let's suppose this is going to S1 server, and then when coming back to the load balancer, balancer request will go to load balancer, then it will go to the it will decrypt it, then it will send S1, then S1 will send the request response this request response back to the load balancer. It will encrypt it again, it will encrypt and send to the user, and there it will get decrypted again. Now that is a backend expensive operation, but it will handle it on its own. So that is one thing. Second is why I named it as SSL termination, because it removes the requirement to install X.509 certificate. Not required because we are already handling this encryption decryption to the server. So no data is getting exposed and we are safe of getting hacked, right? Or getting so session persistence. Second is session persistence. What is this? Okay. So these are basically benefits of using load balancer. Second is session persistence. So issue cookies and route a specific client's request to the same instance if the web apps do not keep track of sessions. So it tries to issue cookies and route the specific client request to the same instance. So have some cache. Load balancer has some cache on its own. Like if user one has already made a request to load balancer, it is coming second time. So it will try to navigate to the same server which it navigated earlier. So there is some caching involved in the load balancer. Okay. So that is like session persistency that happens in the load balancer. This were the advantages of using the load balancer, but there are also some disadvantages. Let me show you. So disadvantages of LB load balancer. Okay. First is the load balancer can become a performance bottleneck if it does not have enough resources or it is not configured properly. Of course, if anything is not configured properly, it becomes an headache instead of providing us benefit. Okay, so configuration is not good, performance goes down, right? Second is what? Introducing a load balancer to help eliminate a single point of failure results in increased complexity. Of course, when you configure a load balancer, complexity increases because now you have to configure two servers, right? Complexity increases. Now, third is what? A single load balancer is a single point of failure. If you have, this is one another problem actually. You know, like you have S1 server, S2 server, S3 server, but only one load balancer. Then if this load balancer fails, then it's in a single point of failure. So I have two load balancer. Okay, I have two load balancers. So we have to configure SPUF. Single load balancer is problem to SPUF. So have multiple load balancers. Okay. So that was about load balancer advantages and disadvantages. Okay. Now let's learn about load balancers versus reverse proxy. Load balancers versus reverse proxy. So anyone of you have any idea what is reverse proxy? If yes, if no, let's try to learn what is reverse proxy. It's very interesting topic. So load balancer is easy, right? We understood what load balancer is. Now let's learn about reverse proxy. Like first is deploying a load balancer. Deploying a load balancer is useful when you have multiple servers, right? Often load balancer route traffic to a set of servers serving the same function that we have learned. Now what is reverse proxy? Reverse proxy can be useful even with just one web server or application server opening up the benefits described in the previous section. So reverse proxy can be useful even with just one web server. Even if you have only one web server, let's suppose you have only S1 server, then to reverse proxy can be useful. So solutions such as Nginx and HA proxy can support both layer 7 reverse proxying and load balancing. Okay. So like Nginx is example of reverse proxy, and HA proxy also is an example of reverse proxy. So it manages 7 reverse proxying and load balancing. Also reverse proxy, if I have S server, your reverse proxy will sit in front of the S1 server like one or more servers, whatever you have, it will sit in front of them and it will forward your request to the appropriate server. Now, how it helps? It helps in hiding the server IP. It helps in hiding server IP. So our IP is not exposed. IP of actual server is not exposed to the client. So that's how reverse proxy works. Okay. What are disadvantages of reverse proxy? Okay. Disadvantages. There is also a type of load balancer, I would say. Disadvantages of reverse proxy. What are disadvantages? First is introducing, of course, complexity increase, because if you introduce any new service, more always increases. That's a common disadvantage, right? A single reverse proxy is a single point of failure. So again, the same sort of disadvantage that we have in load balancer we have here, which is don't have single reverse proxy. So single reverse proxy equals to SPOF, single point of failure. So I have multiple reverse proxies. Now comes a load balancing algorithms. So there are load balancing algorithms. Whenever you try to load balancers, there are some algorithms which you can follow. Let's learn about it. Load balancing algorithm. What are load balancing? So load balancer is a software or hardware device that keeps any one server from becoming overloaded. That we have learned. A load balancing algorithm is the logic that a load balancer uses to distribute network traffic between servers. An algorithm set of predefined rules. Right? There are multiple load balancing round and other sort of things, but we are just doing the definition of what load balancing algorithms are. So like there are two primary approaches to load balancing. Two primary approaches: dynamic load balancing, which is dynamic load balance. Also, what it does, it uses an algorithm that takes into account the current state of each server and distribute traffic accordingly. So it takes in account current state of each server and writing is and try to distribute load accordingly. This is the dynamic load balancing. There is a static load balancing. So it distributes traffic without making. So some static algorithms and equal to each server in a group, either in specified order or at random. So whatever server it has, it will send to a request to this without checking current state of each server. Also there are other types as well, but these are dynamic load balancing, dynamic. In dynamic, I guess there is robin, and other sort of things. Let me just show you. Load balancing algorithms like round robin. Okay, so there is immediate round robin, there is dynamic round robin. So like round robin, also algorithms. If I go to GS, you can see here now there is static and dynamic. One more example, and let me just show you other ones. Actually, I haven't put any. Yeah, immediate round robin. Yeah, one is hash load balancing. So source ID. Yeah, you can use hash to load the balance. Dynamic load balancing, we have already saw that. And what else? Least response time method load balancing algorithm. What else? Resource based balance algorithm. Okay. What else? Yeah, if you go more deeper, you can find more. But yeah, those are the basic ones. Let's go to this our notes. So that was about load balancing algorithms. Now layer 7 load balancing. Let's learn about layer 7 load balancing. Layer 7 load balancing. So what are layer 7 load balancers? So layer 7 load balancer look at the application layer to decide how to distribute requests. So it look at the application layer to decide how to distribute request. This can involve contents of the header messages and cookies. So it try to check the application layer, like request has some application layer, right? So it try to check the header messages and cookies. So this balances terminate network traffic, reads the message, makes a load balancing decision, then opens a connection to the selected server. Okay, so you try to read the request, try to read the whole request and analyze headers, messages, so headers, messages, and whatever content we have, and then it try to select one server from whatever server available servers and then try to forward the request to that server. Like for example, a layer 7 load balancer can direct video traffic to servers that host videos while directing more sensitive user billing traffic to security hardened servers, right? So let's suppose in headers we have video request or some JPEG or JPG image or there is MP4 video or whatever things that we are requesting in headers or messages. So we have different server configured for let's suppose this is for video. This is for uploading image. Okay, this is for uploading image, which manages via S3, and this also manages via another S3. And there is one server for what? Billing. So it tries to analyze the header. Our load balancer try to analyze the header. This is our load balancer. So this will try to analyze the header and forward the request according to the headers. Okay, so these are layer 7 load balancing. At the cost of flexibility, layer 4 load balancing requires less time and computing resource than layer 7. Okay, and the performance impact can be minimal or modern commodity hardware. Okay, so that depends on the complexity. Now layer 7 load balancing is done, right? Layer 4 load balancing. So layer 4 load balancing, layer 4 load balancing. Okay, so what is layer 4 load balancing? So layer 4 load balancers look at info at the transport layer to decide how to distribute requests. Generally, this involves the source, destination IP, address, and ports in the header, but not the contents of the packet. Okay. So this type of load balancers, what it does, it try to check the IP address and ports in the header. So whatever ports we are trying to request in the header, it will try to check and forward the request to that server. And layer 4 load balancer forward network packets to and from upstream server, performing a NAT, network address translation. Okay? You can go more deeper to this, but yeah, that's all about it now. Now comes horizontal scale. Load balancer is done. Right? Type of load balancers are done. And now, so what were the type of load balancer? Load balancing, layer 7 load balancing, layer 4 load balancing, and dynamic and static load balancing, of course. We have also seen reverse load balancing versus reverse proxy. There is also forward proxy, but that is not right now. We won't be looking into it. So let's learn about horizontal scaling. Horizontal scaling, you might know. This is the basic system design thing, right? So horizontal scaling. Horizontal scaling means you add more servers. So that's what horizontal scaling. Vertical scaling, you enhance the parts of your CPU or your server. You increase RAM, you increase CPU, you increase graphic GPU. Those sort of thing is a vertical scaling. Horizontal means you add more servers with same configurations. Okay, so load balancer can also help with horizontal scaling, improving performance and availability. So scaling out using commodity machines is more cost efficient and results in higher availability than scaling up a single server or more expensive hardware called vertical scaling. Right? As I said, it is also easier to hire for talent working on commodity hardware, and it is specialized enterprise systems, right? So basically horizontal, if you do horizontal scaling, it can help in load balancing because you will have more server to balance your load. So that's how it can help. Now what are disadvantages of horizontal scaling? What are disadvantages? First is scaling horizontally reduces complexity. Of course, complexity increase because you have to configure more servers on your load balancing register, and depending on the type of algorithm that you have used, it will be more complex. So complexity increase. It servers should be stateless. They should not contain any user related data like sessions or profile picture sessions. And what is the second disadvantage? Downstream servers such as cache and databases need to handle more simultaneous connection. Upstream servers scale out, right? So downstream server like such as cache or and database. Downstream means those servers which have cache and other things which doesn't do much of computation. So those need to handle more cache and database to handle more simultaneous connection than if upstream server is scaled out. So that's all about load balancers, guys. Thank you.